In progress.
Good morning, everyone. Today I'm going to talk about the machine learning and sports science challenges and opportunities. As we know, machine learning focuses on the creation and use of models that have learned from data and perform a classification. In this slide, we can say that it has an impact on the devices used to acquire data to improve the interpretation of a sport performance, injury risk prediction, as well as informed rehabilitation practices along the classification models. As a matter of fact, sports scientists could benefit from knowing about the processes that support machine learning techniques and its practical application, and it has connection in this field. We can see here in Figure 1 the processes of feature-based machine learning and the potential challenges associated with each of these processes. While it's not necessary for sports scientists to comprehend the mathematical and statistical principles that support machine learning, it's important that they understand certain key concepts such data capture processing, feature selection, modeling, and evaluation before using it as a component of the research toolkit as shown here in Figure 1. About data capture processing, when applying machine learning, it's important to capture an enough large data sets. In most cases, the more data, the better, as this will provide the model with more opportunities to learn. Previous studies using injury prediction machine learning models have used greater than 400 or greater than 700 samples. About modeling, it should be noted when seeking to develop a machine learning model, it's common practice to evaluate multiple techniques and feature a combination to find the most appropriate model given they differ in their abilities to learn, such as regression, decision-free, and neural networks, among others. At the same time, it's important to consider the danger of overfitting that could be caused by unsuitable ratio between input feature and observation within the data sets. Let me see here. Table 1 shows a binary classification confusion matrix and measure that can be directly calculated from it, such as recall, sensitivity, probability of detection, power, miss rate, specificity, among others. You have to note that confusion matrix represent counts from predicted and actual values and determine the accuracy of the model. Let me see here. Regarding evaluation, an often used measure to evaluate the performance of machine learning model is accuracy. Using accuracy is an injury prediction study is likely to yield an excellent result, even if the model has learned nothing. For example, 98% accuracy can be achieved by always predicting no injury if 2% of the observation get injured. To ensure the quality of a model, let me see. The best practice is to set aside a portion of the data which only used for the evaluation of the model. I mean, testing data for cross-validation during the fitting process, as we see here in table 2, possible option. And regarding the good discussion and implication, as a final conclusion, we can say that that over the next decade, machine learning is likely to greatly enhance the quality of decision making in sports science. Studies has demonstrated that these techniques can predict feature injuries, 85% precision, 85% recalls based on precision measure, identify movement strategies, enabling the identification of movement, specific injury risk factors, and identify and injury individual who demonstrate movement patterns that are similar to injure individual. So that's all for me. Many thanks for your attention. Ay, no me digas que no grabó.